Okay, so we want to make a more general statement about the way the energy can change. And so let's go back to thinking about some object of mass m, a block of mass m, that we drop from some height h, or we launch it downwards from some height h. We know that this system has an energy, which is the kinetic energy plus the gravitational potential energy. And that's the total energy. If the energy is conserved, it remains that value, even as the object falls, of course. We can rewrite this as the object falls with varying values of the velocity. The velocity will increase as it comes down, and so the gravitational potential energy will decrease as the y value decreases, but the total will remain constant. So in a situation like this, we can say the energy, let's say some configuration, we have a total amount of energy E1, which is due to some kinetic term K1 plus some potential term U1. And if we do, we can imagine changing this configuration. Let's add some energy, or take some energy away. So let's say we decide to launch it downwards with a greater speed, such that the kinetic energy is now different, or less speed, so the kinetic energy is smaller, but different. Then we have a situation that looks like that, V2, and then we can say, well, there's a difference in energy here in the system, right? We transferred some energy, took some energy out by, when the object comes, let's say it comes back up, it's a bouncing ball or something, and energy is conserved in the collision, comes back up, and then we take some of the energy away by decreasing the speed the next time it comes down. We change the kinetic energy, so in this case we would say something like the delta E, the difference in energy is K2 minus K1, and so the difference in energy is due to a difference in the kinetic energy. We could contemplate an energy 2 given by a change in the potential energy, so it looks something like that, in which case we would say there's a difference in energy in the system, which is due to U2 minus U1, or difference in the potential energy, delta U. So more in general, we can say that there's a delta E, which is due to a delta K and a delta E together. And of course, we can say that, right, if energy is conserved, then there's no delta E, then delta K equals minus delta U, and of course, minus delta U is the work, so we can say that it's minus the work. But now we want to generalize this, because our block is really not to be considered as some object without any structure. We now we're contemplating the molecular nature, the atomic nature of this object, and there are molecules or atoms moving around, right? We've sort of explored this in the ideal gas case, but this is true more generally. And so we're going from this kind of a thing to this kind of a thing, and so we now have to take into account the energy that we have there. So we've noticed that if the pressure, if this is an ideal gas, if P and or the volume change, then we have an extra W term. We have an extra work term, which is the area under the curve. But we also saw that T, the temperature, can change. We can imagine a change in PV such that temperature doesn't change, but then we also saw that T may change, so T can change as well. And T, of course, is equal to, we saw this, we derived this relationship, the constant K, Boltzmann's constant. T is proportional to the average kinetic energy of this object, of this collection of particles, of molecules. And so we have a delta K term, a difference in kinetic energy, associated with this change in the average, in the motion of the molecules. And we call this we call this a generalized change in kinetic energy, heat. It's the transfer of energy by heat. And so we have a more general expression, delta E, right? Delta E is equal to heat, or we usually use the symbol Q, so that it has to do with heat change and work. So it looks something like that. Of course, this could be negative and therefore make this positive. So changes in transfers of energy by heat or by work will change the energy of this kind of a thing. And this is really the more general conservation of energy. It's really the way the energy can change. It's called the first law of thermodynamics. So we'll explore this in more detail.